So I'm going to start things off this afternoon talking about evaluation of nutrient management and irrigation management BMPs in Southern Alberta. I'm going to first go through a little bit of a background and then an overall overview of our project, and then I'll talk about the irrigation management sites in a little more detail. So as you guys know, Alberta's increasingly become more urban. We're over 80% urban in our province. It was similar actually to the US statistic that was talked about this morning. We're 20% rural, and that public views agriculture as being a major source of environmental degradation in the province and other places around the world. Overland runoff is just one of the main ways that agricultural nutrients enter waterways. And too many nutrients can lead to algal blooms, aquatic weed infestations, odors, fish die-offs, and can be, especially with high nitrate levels, there can be concerns about animal health safety. Some of you are familiar with our Alberta Environmentally Sustainable Agriculture Study. We monitored 23 watersheds, agricultural watersheds at the outlets for a number of years. It was actually an aftermath of the CASES study. So from about 1992 to 2007, we collected a lot of data, land cover, water quality data, and some of the main outcomes of that study were that as ag intensity increases, water quality deteriorates, not surprising. Ag practices are definitely contributing to the degradation of water quality. And nutrient concentrations exceeded our guidelines in the province at that time, although now we don't have guidelines for nitrogen and phosphorus. Now we have site-specific objectives. A lot of you are aware we have regional plans under the land use framework. So now we have site-specific main stem river objectives in the province, and agriculture will be expected to help contribute towards meeting these objectives. The next study that we were led into during the ASA time actually was the phosphorus limits study. In that study, a relationship was established between soil test phosphorus and runoff phosphorus in our study, and we looked at 8 different micro watersheds throughout the province. However, the recommendations at that time were that soil phosphorus limits should not be legislated until we develop, test, and demonstrate BMPs that work in Alberta. How effective are these BMPs? We do have BMP manuals, we do offer advice, but how effective are they? What are the costs? And what social challenges exist with implementing these BMPs? So a year ago, we started the nutrient BMP study, and we had a number of objectives we wanted to address within the study. Like, we wanted to evaluate the environmental effectiveness and economic costs of the BMPs at the farm scale, assess these impacts at a watershed scale, and predict the cumulative impacts using models as well. We wanted to evaluate nutrient management BMPs for effective use of manure and crop production, and apply these results on a provincial scale. Some of our partners included producers in the watersheds. Obviously, we couldn't do this work, it was volunteer basis, and we couldn't do this work without their partnerships and cooperation. The Alberta Crop Industry Development Fund kicked in dollars for this project, as well as Alberta Environment. Agriculture and Agri-Food Canada was also a partner through AESB at that time. The MD of Pindar Creek, Lacombe County, the universities were also participating in aspects of the project, and we did apply for funds for a bioengineering project with the Alberta Conservation Association. So some of our study accomplishments: we established 22 BMP sites, 52 monitoring stations, 8 weather stations. We collected a whole lot of data, worked and collaborated with the producers, established a couple of watershed groups. We were also partnered with the Texas Institute for Applied Environmental Research, because I always forget my acronyms, and we gained a whole lot of watershed research expertise working on this project. Oh, and we are working on our final report. We finished collecting data in 2012, and we are just finishing up our final report now. There's been so many drafts, you have no idea. Project length was 6 years, so from 2007 to 2012. The study design was basically 2 to 3 years of pre-BMP monitoring. Then we implemented the BMPs, and then we monitored for an additional 2 to 3 years. Or 4 years, depending on the site. So what we were trying to do is we wanted to evaluate the pre and post BMP periods We used upstream and downstream when we could, particularly with respect to in-stream water quality. We used the Mann-Whitney statistical test. It's a non-parametric test rather than a GLM like SL means type of parametric test for evaluating the BMP periods, and all descriptive stats were done in SAS. So the types of BMP sites. We had 8 traditional kind of manure nutrient management on annual crop field type of sites. There we developed nutrient management plans and worked with the producer on implementing them. And there were a couple sites where we asked the producer to move from a surface applied manure application to injection with respect to the liquid manure sites. We had 10 livestock management sites. Those sites varied. There was off-stream watering at quite a number of them, in some cases fencing and livestock exclusion, rotational grazing in the paddocks, the various paddocks created within the farmstead, and sometimes relocation of facilities. Like we did remove an old corral and we moved winter and bedding feeding areas as well. And then we had some surface water management sites. So there was one site, it was a feedlot where we did some berming and redirecting of run-on water at that site. That was quite a bit of work and quite costly. And we also did some buffering and grass channel waterway establishment, BMPs, and modifying irrigation. So where are these watersheds? Indian Farm Creek watershed was just southwest of Pincher Creek, and it's in the Fescue grassland sub-region of the province. Whelp Creek was north of Red Deer within the central parkland region of the province. And our 2 irrigation management BMP sites were in the Battersea drain and Lower Little Bow watersheds within the province, just northeast of Lethbridge. So to give you an idea what hydrology is like on average within these watersheds, in the central parkland, what we tended to see in our ACES study, and ACE and CASES study, was that the average hydrograph tends to look like this in the agricultural watersheds. Most of the runoff occurs during snowmelt in March and April. However, in the Fescue grassland ecoregion, at the smaller agricultural stream scale, we tend to see more of our runoff in June and late May due to heavy rainfall runoff. Although there's huge variations, as you guys know, John Pomeroy talked about that this morning. Like we have years where there's drought years or flood years, and obviously these hydrographs shift a bit, but on average this is what we tend to see. And in the highly managed irrigation districts within the province, your hydrograph tends to be much more leveled off, less steep of a peak, because the irrigation district is controlling water through the irrigation infrastructure. And obviously most of the supply water is being pumped through the system during the growing season from about mid to late May to late September, early October. And these are the average hydrographs from our study for the watersheds, and for the most part they kind of resemble these average hydrographs. The exception would be Whelp Creek. We actually did see substantial rain storms in July, in June and July in the latter part of the study. Just emphasizing again the variation in the climatic variability you can see within the study. So in terms of soil test phosphorus, within all of these sites, you can see that in the cultivated non-manured fields there tends to be lower soil test phosphorus, which is what we would expect. We do have a couple reference sites, or a few reference sites there that were lower in phosphorus, and we purposely picked them for the choice of having a few reference sites. Cultivated manured fields are a bit higher. Our pasture sites were kind of variable in concentrations, but that's because there were hot spots there. There were bedding and feeding areas as well associated with those sites, so that's why there's variability there. Oh, and the Lower Little Bow Battersea drain field on the far right, those are irrigation management and heavily manured sites. And you can see, with respect to runoff total phosphorus, the highest soil test phosphorus sites also had the highest runoff total phosphorus concentrations. The dairy manure field site was a bit of an interesting site because the producer there, he doesn't have manure storage, so he had to apply his dairy manure pretty much every day until the growing season, and he just didn't have a lot of storage, so he had some built up soil test levels there. but not as high as our annually applied heavy manure field sites. And those are the two sites I'm going to be focusing on next. They're irrigation management sites as well. So the Lower Little Bow site was 2 irrigated quarter sections. The rotation at this site was silage, corn, barley, silage, and canola. Loam soils, relatively, well, quite high beef cattle manure applications, and pretty much on an annual basis. We soil sampled in the spring and fall, and we developed nutrient management recommendations on the fall soil samples, and we used AFFIRM for our nutrient management recommendations. And AFFIRM, Alberta Farm Fertilizer Info and Recommendation Manager. Sorry, Len. I always call it AFFIRM. I never call it by the full name, so I'm really sorry. I had to write it down on my hand. Sorry about that. But we did use AFFIRM for our nutrient management recommendations in the study. And you can see this site had quite high soil test phosphorus levels, ranging between 221 and 347 milligrams per kilogram. We monitored this site at one edge of field sampling point at 101 in that map there, image there. The Battersea drain field was a little bit more complex in terms of monitoring it, but it was 1 irrigated quarter section. The rotation was potato, corn, silage, canola, and barley, sandy loam. Again, heavy annual beef cattle manure applications. Again, nutrient management recommendations through AFFIRM. The soil test phosphorus levels were even higher at this site, ranging from 300 to 500 milligrams per kilogram. And we monitored this site at 4 different edge of field stations. 203 was actually a ditch, like running along the ditch site. So we were able to monitor ditch water at that site. And then 204, 205, and 206 were edge of field stations where we were actually monitoring irrigation, rainfall, and snowmelt runoff. And we also monitored within the Battersea drain itself, upstream and downstream of this site. So in terms of the BMP implementations, there were a number of things that we implemented. One was the nutrient management plan. Well, obviously, with that high of soil test phosphorus levels, the recommendation was no phosphorus to be added. So what we had to ask the producer to do was to cease manure application. We offset the cost of transporting it further, and these ended up being 2 of our most expensive sites. Well, our water management site, the berming and redirect and run-on was quite expensive as well, but it was extremely expensive to do this. We also put a panel on the irrigation pivots, and we were able to, the program allowed us to turn off the end gun and the last span of the irrigation pivot so that it wouldn't irrigate over hydrologically sensitive areas within the field. So in those, in the runoff zones that we were collecting in. And we also did some irrigation scheduling through the Alberta Irrigation Management Model, another acronym, AIM model. And we provided the AIM scheduling output every week to the producer, and then to let them know how much they should be irrigating that week. And that's based on soil moisture levels, crop growth and development at that time, rainfall that would have occurred that week, and the soil moisture levels like from the beginning of the study. So it takes all these things to account. And we also established a grass waterway at the Lower Little Bow site. So in terms of water quality, I just want to mention, I'm just going to focus on Lower Little Bow because Battersea drain it takes a little bit more to explain, but our results were similar at both sites. But we didn't have a snowmelt in the pre-BMP period at these sites, so we weren't able to evaluate the snowmelt period. But during the growing season, we had significant reductions based on ceasing manure application or other BMPs, lower nitrogen and phosphorus fraction concentrations, and lower E. coli as well. However, the suspended solids were a bit of a trouble for us in 2009 because the farmer accidentally sprayed out the grass waterway we had just seeded. So we re-established it, but was later in the season. Or it was like in June, I think, when we reseeded it. So we decided to look at the data with and without 2009, and when we took it out, we could see the suspended solids actually looked low, or they were significantly lower. However, if we include 2009, they were actually significantly higher. In terms of the soils, you can see in the spring they're around 200 30 milligrams per kilogram, and in the fall around getting close to 300 milligrams per kilogram. But our post-BMP period, we didn't see significant reductions. We expect that there's probably soil microbial and geochemical mechanisms going on that allows the soil test phosphorus pool to be regenerated and maintained each year. And at a site with this high of phosphorus, we expect that that would continue for a number of years. However, we did see significant decreases. They were small decreases, but in soil ammonia and nitrate. And again, these sites were, this site was similar to the findings at the Battersea drain field site. I had mentioned the phosphorus limits study, so we also wanted to look at the relationship that Joanne and others had established. We wanted to look at, so if you can see, the orange dots there are runoff versus STP results from this study, and then the blue squares, sort of in the middle range, the 200-300 milligram per kilogram range, are from the P-Limits study. And you can see that generally the soil test phosphorus levels were similar, but the runoff concentrations became lower during our study, and we think that's due to our BMP effect. However, yeah, we haven't seen that, we didn't see that effect in the soils. In terms of looking at runoff management or irrigation runoff, well, our volumes got higher the further along in the study we got, so it was hard to evaluate. However, if we look at the percent runoff volume attributed to irrigation runoff, then we can have a better idea of what's going on. In our pre-BMP period, you can see that 2007 was actually quite dry. And we didn't have, most of the runoff that year was due to irrigation runoff because we didn't have a significant snowmelt, and we also didn't have very much rainfall. And 2008, we had a huge rainfall peak on, it was in late May, and I think it was about a third or so of the rainfall occurred in one day. So it was wet at that time, but the rest of the season, the producers still needed to irrigate because that most of the precipitation occurred in that event. 2010, no irrigation was required. It was so wet. I don't know if you guys remember 2010 for us in the south that year, but it was an extremely wet year, and there was flooding all over at that time. And yeah, so in terms of the irrigation or the runoff volume that was attributed to irrigation, it does seem to be lower, but it is really hard to piece it out because the volumes are so much larger during those high precip years. So in summary, fields with history of manure had higher soil test phosphorus, and the fields with history of manure had higher concentration of phosphorus in the runoff as well. The grass waterway at Lower Little Bow seemed to help reduce the sediment and particulate phosphorus concentrations. And the cessation of manure did result in lower concentrations of runoff, but this didn't translate into lower soil phosphorus concentrations in soil.